Good morning. Hope everyone's doing well. Dum-de-dum. Guess I'll eat my banana while waiting for people to join. What do you guys do with this part of the banana? Do you eat that part of the banana? I take it off usually. It's kind of the gross end of the banana. I agree. That's probably what YouTube is going to choose as the thumbnail for this class. It seems that their algorithm is, like they'll choose some sort of big motion as the algorithm. Like if I go, whoa, that's going to be the thumbnail. Once I finish this banana, we will begin. Hello, people who are rolling in. Hello, hello. Hello. We are starting once I finish this banana. And I have one more bite. Good morning. Buenos dias. Okay. Hope everyone's doing well. Hope everyone had a nice weekend. I'm going to go ahead and get started. I don't know what the deal is, why this camera, it's like it doesn't fully autofocus all the time. Maybe if I turn the light on and then I autofocus, maybe it'll, oh, okay, there we go. Cool. All right, so as usual, I'm going to start with the SL students. And for the SL students, we're going to be talking today about continuing on our discussion of arrays, multi-dimensional arrays. Okay, so when we were declaring an array, let's say we were declaring an array of integers, you would say int, like this, open square bracket, close square bracket, my array equals new int, and then we have to put the dimensions of the array. So maybe it's an array of length 100. I don't know. Okay, so that's a one-dimensional array. If you have an array of dimension 2, then you would declare that by saying int and then you actually have 2 brackets that open and close. So that's a 2-dimensional array. I'm going to call it m equals new int, and then again we have to declare the dimensions over here. Okay, so maybe I have this be a 3 by 5 array. Okay, so what does that mean? Well, we can think about a 2-dimensional array as a matrix. Okay, so you know, I can think about this as a 5 by 3 matrix. So I don't know, if I just made it all zeros, it would be something that looks like this. Okay, and so this would be the 0,0th element. This would be the 3,5 element, or not 3,5, my bad. It would be 2,4, because remember we start at 0. So we 0, 1, 2, 3, 4. 0, 1, 2. So this is the 2,4 element. This one right here would be the 2, 0 element. This right here would be the 0, 4 element. Okay, so yeah, it's a matrix. Okay, so we could think about the second index here as the column number. Okay, and then we can think about this as the row number. So we have a row number and we have a column number. So this has 3 rows and 5 columns, and these are just labeling. So we can identify a specific number in the array based on that. Okay, so I don't know, what if I made this 1? This equal to 1. Then this is column number 0, 1, 2, and row number 0, 1. So I would have, basically that means that m of 1, 2 equals 1. Get what I'm saying? Let's suppose that this is 42. Then I would have, this is row number 0, 1, 2, column number 0, 1. So this would be 2, 1, and 2, 1 equals 42. Okay? So to initialize a 2D array, what you want to do is you want to use nested for loops. Nested for loops. So basically, I don't know, what you'll do is you'll do for, let's say int I, let's say I wanted to iterate all over this. So I wanted to initialize a 3x5 array. Then I would say int I equals 0, I less than, we're going to do 3, I plus plus. So this is going to iterate over the rows, okay? And then within that, I iterate over the columns. So I have a second for loop. So int j equals 0. J is going to be less than 5 because it's going over all of the columns, and there are 5 different columns. And j plus plus. Okay, and then we would say, you know, maybe mij equals something, do some code, okay? So if you have a 2D array, you need to use nested for loops, a for loop inside of a for loop. The outer for loop does the columns, or sorry, the rows, and then the inner for loop does the columns, okay? You are not limited to two-dimensional arrays. You are not limited to two-dimensional arrays. You can have three-dimensional arrays, four-dimensional arrays. You just are going to continue the same pattern. So if I wanted to declare a three-dimensional array, int, I would just have three square brackets, open and close, equals new int, and then, I don't know, maybe I want to make it a 4 by 50 by 10. So you could think about this as a, you know, if a two-dimensional array is a grid of numbers, a one-dimensional array is a line of numbers, a three-dimensional array you could think of as a cube of numbers, okay, where there's a number at each, you know, location within a cube. Four-dimensional arrays, you could do that. You could define a four-dimensional array in the exact same fashion. Okay, so that's how multidimensional arrays work. So let's go to CodeBoard and see how this works in practice. So here's CodeBoard. So let's suppose I have an int. So that's a two-dimensional array m equals new int, and I'm going to make it a 5 by 4 array. Okay, so this array as it stands is uninitialized, which means that the values within this array have not been set yet. So I have to initialize it, and I'm going to initialize it with a nested for loop. So I have for int I equals 0, I less than 5, I plus plus. So that is going to iterate over each row. So this has 5 rows and 5 columns, or 4 columns, excuse me. All right. So now, there's my first for loop. Now I have to have an inner for loop. So for int j equals 0, j is going to be less than 4, j++. So this is iterating over the columns. And then I'm going to have m, I, j. I have to set those equal to something. So maybe I set them equal to I times j. Okay. So that's something I could do. So I initialize the array with nested for loops. So now what if I did something like system.out.println? What if I printed m for 3? All right. So what is that going to output? Well, the ijth element of this two-dimensional array is I times j. So this should print out 4 times 3. So this should print out 12. Let's see. Let's compile. Run it. 12. Okay, so that works as expected. What if I wanted to get the length, the number of rows in this array? Okay, so we talked last time about using the dot length to get the length field of the array object. So dot length will get you the length. But when we have more than one dimension, it's a little bit confusing. It's like, which length does that refer to? Does that refer to the 3 or to the 4? Okay, so let's see what happens. And we can see that that spit out 5. Okay, so basically the takeaway here is m.length returns the number of, remember that first number is the number of rows. Okay, so if you do m.length, it's going to return the number of rows. To get the number of columns, you do m0.length. Okay, so this should return 4 for the number of columns. So let's compile it. And sure enough, it returns 4. Okay. So the takeaway there is m0.length returns the number of columns. Okay, so I thought it would be fun to make a little method that prints this grid of numbers. So I'm going to create a method down below the main method. So this is a method that is completely separate from main. So this is going to be a public static void method. So it returns nothing, it's public, and it's static. So it's a method of the main class, not of a particular object. And I'm going to call it print matrix. Okay. and it's going to take in an array, which I'll call M, an int array, excuse me, that is two-dimensional. Now we'll call it M. Okay, so this is a method that takes in a two-dimensional array of unspecified dimensions. If I wanted to, I could specify the dimensions by doing something like this, but you're kind of writing more general code if you leave the dimensions out. So what I want to do is I want to say for. So again, nested for loops are sort of the thing to do with multidimensional arrays. So for int I equals 0, I less than m dot length. Okay, so that's going to iterate over the number of rows. Okay. We got to do something. So then I'm going to have my inner for loop, int j equals 0, j less than m 0 dot length. So this second for loop is going to iterate over the number of columns, just like we've discussed up here. Okay, and so now what we want to do is we want to do something. So what I want to do is I want to do system.out.print m ij. Okay, but then I also want to put like a space between the I want to put a space between each number, because if I didn't put a space, it would be kind of confusing to read. Maybe I'll put 2 spaces between them, something like that. All right, so this is going to print each, because this is iterating over the number of columns, it's basically going to print the entire row, and then it's going to go to the next row, and then the next row, and the next row. Once I get to the end of the row, I want to put a space in, right, or return. So I'm going to, outside of the inner for loop, so at the end, once it has completed iterating over the entire row, at the end of that row, I'm going to put a carriage return. So print that. Print a carriage return /n. All right. So I don't need to have a return type because it's a void method. It's just going to print that. So that should work. Okay. Should is the key word. So now what I want to do is I want to do print matrix of my matrix M. Okay, so that should print the matrix. Nice. Here it is right here. So see how I printed that matrix. That looks pretty good, actually. So if we think about it, this was a what? It was a 5x4 matrix. So this 12 here is the 3/4 or 4/3, excuse me, element of that matrix, and we can see it printed 12 here. This would be the 4/2 element of the array, so that gives 4 times 2, which is 8, etc. All right. If I wanted, I could just initialize the array with a bunch of random numbers. So I could do math.random, let's say and then we have to turn that. We did this the last lesson where we did a random array of integers between 0 and 100. Let's compile that. So there we have an array of random integers. All right, so that is my lesson for the SL students. Okay. So there you have it. So I want to talk to the HL students now. So we're going to learn about our next data structure. Our next data structure for the HL students is called a binary tree. So let me tell you about binary trees. Binary trees, they're called, so binary tree is essentially a tree of objects. So maybe it's 4, 3, 2, -1, 7, -5, so we have a tree structure like so. I have this one. So this is obviously a binary tree of integers. All right. Maybe I will do one more here. Okay. So here's a binary tree. Okay. So you can see, why is it called a binary tree? It's because every object is connected to 2 objects that are below it. Okay. So the 4 is connected to the 3 and the 2. Okay, so these are like the branches of this. There's a single element at the top of the binary tree, which is called the root. Okay, and the root basically has a left child, or a left branch, whatever you want to call it, left branch, and it has a right branch. Whoa, okay. So it doesn't necessarily have to have both a left branch and a right branch. So for example, you know, this 3 right here has a left branch of 10, but no right branch. Okay. This 4 has a left branch of 3, but no right branch. Anything at the bottom of the tree is going to have, you know, neither a left branch or a right branch. Okay. There's something called the depth of the binary tree, which is basically the maximum path from root to a leaf. Okay, so if I think about this, what's the maximum path? I have 1, 2, 3, 4, 5. Okay, so I would say that the depth of this binary tree is 5. Okay, because there are shorter paths to a leaf. There's, 1, 2, 3. There's 1, 2, 3, 4. 1, 2, 3, 4, but it's the maximum path, okay, is the depth. Okay, so let's talk about implementation, because as you might have guessed, you guys are going to implement a binary tree for today's assignment, and you're going to write some methods for a binary tree. So usually a binary tree is created with two classes. So you have a class that is called, tree node. Okay. The class tree node is going to basically have the object. Okay. So I have made a, this is a binary tree of integers. This is the most common thing to have a binary tree of, is integers. But it doesn't have to be. It could be a binary tree of two-dimensional arrays. I don't know. So you have the object itself. So the object is 4. Okay. And then you have references to the left branch and to the right branch. Okay. So for example, let's consider this one right here, the 3. So the object would be 3. The left branch would be 10. You wouldn't actually put in 10. You would put in the variable for, this would be references to the left tree node. Okay, so maybe this tree node is called, T. So you would say left tree node equals T, for example. And then because this has no right branch, what you want to do is you want to set the right branch equal to null. So null means that there's just nothing there. Okay, it's a valid protected name in Java. So you would just say null, lowercase n-u-l-l. Okay, so you have a tree node. Okay, and then really your binary tree class is going to contain a tree node, which is the root. Okay, so basically the binary tree class is you only have where the root is, and then you just follow the root down the tree wherever you want to go. Okay, so kind of like a linked list, it's like you might just have the head of the list and you have to follow it all the way down. Same thing with a binary tree. Okay, so you just have the root stored in there, and then you have any methods that you want to include. Okay, binary trees are perfect for recursion. Okay, so you always want to be thinking recursion with binary trees. Okay, why is that? Well, basically you can go through, so to go through the entire tree is called a traversal. Okay, so to traverse the entire tree, what you could do is you could do something to the tree node object. Okay, and then you do do something to the left branch recursively, and then you do something to the right branch recursively. All right, so you can go through the entire tree that pretty easily like that. So you definitely want to think recursively for some of the methods that I'm going to have you write today. All right, so that's my lesson. I will see you in the Zoom room. Okay? See you soon.